Today I will talk about how to use the abacus for fractions and decimals. The abacus is useful for factoring, simplifying fractions, changing to and from mixed numbers, common denominators, adding, subtracting, multiplying, and dividing of fractions. The abacus is used for writing down the intermediate steps, which are too big and complicated to keep in your head. A student could use their Brailler or Braille note taker to write down these steps, but the abacus is much faster and easier. I try to introduce the abacus technique as the student is learning the fraction concept in class. So let's start with factors, which are the numbers that multiply to equal a number. Eventually, the student will be asked to have the factors in order from lowest to highest, so I have the student set the lowest factor on the left side of the abacus and the highest factor on the right side. That way they'll already be in the right order. Have the student leave one empty rod between factors so that they can read the answer easier. Some books say to put them next to each other, but I find it's way easier to leave one empty rod. For example, the factors of 12 are 1 times 12, so we would write 1 on this side and 12 over here on the right side. And then 2 times 6, so we'd write 2 and 6, and 3 times 4, and I would write a 3 and a 4. So the answer the student will write on their assignment can be read from left to right. 1, 2, 3, 4, 6, and 12. This is used to find common factors for simplifying fractions. Prime factorization is a different process where you end up with all prime numbers. This is used to find common denominators and multiples. I have the student set the number to be factored on the right side. The factors will start on the left side. So I'm going to go ahead and use our example number of 36 and go ahead and set that on the right side. Divide the number by prime numbers, starting with 2 if possible. If it is divisible, you write the factor number on the left side and change the original number by actually dividing it on the right side. I leave one empty rod again between factors to make it easier to read, but you don't have to. So let's try, we have 36. Is that divisible by 2? Yes, so I would write the 2 on the answer side. 36 divided by 2 is 18, so I would just write 18. You could actually divide if you didn't know that already. 18, is that divisible by 2? Yes, so I'd write another 2. 18 divided by 2 is 9, so I would change this to 9. Now, is 9 divided by 2? No, so I can't use 2. Is 9 divisible by 3? Yes, so I would write a 3. 9 divided by 3 is 3. The final 3 is already a prime number, so I don't need to divide it anymore. This means I'm finished. Now I would read my factors and write my answer as 2 times 2 times 3 times 3. And that's prime factorization. Now we're going to simplify fractions. In simplifying fractions, I write the numerator on the left side of the abacus and the denominator on the right side of the abacus. Then I divide each side by a common factor. And then I continue dividing until there are no common factors left. In some books, and some people would put the numerator and the denominator on the same side, leaving an empty rod in between. And you get the same answer. So for our first example, we're going to simplify 6/9. And I'm going to go ahead and use my method, 6 over 9, numerator, denominator. Common factor is 3, so I would divide each side by 3. 6 divided by 3 is 2, so I'd change this into a 2. And 9 divided by 3 is 3, so I change this into a 3. My final simplified fraction is 2/3. Here's a larger example, 6 over 42. So I would write the numerator 6 here, and the denominator 42 here on the right side. Now I'm going to divide by 2 because let's say I don't know that there's another common factor. 6 divided by 2 will be 3, and 42 divided by 2, that's easy, that's 21. Then I ask, can I divide it again? Yes, I can divide them both by 3. 3 divided by 3 is 1. 21 divided by 3 is 7, so I make this a 7. Now I have prime numbers and I can't divide anymore, so my final simplified fraction is 1/7. The abacus is useful for converting improper fractions into mixed numbers. To change from an improper fraction, which is really a division problem, into a mixed number, I write the numerator on the right to be divided and the denominator on the left as the divisor. Then do the actual division, leaving the remainder if it has one. That remainder becomes the fraction part of the mixed number. So let's start with an easy example of 3 halves. That's really 3 divided by 2, so it's 3 halves. Then you do the division problem. 2 goes into 3 one time. Take away the 2, and my remainder is 1. So my answer is 1 and 1/2 as a mixed number. I'm going to clear that one. And let's try something a little harder. If I have 17/5, I'm going to write 17 over here on the right side, 5 on the left side. So 17 divided by 5 goes in 3 times. 3 times 5 is 15. Subtract the 15. That leaves me a 2. That's my remainder. So my answer as a mixed number is 3 and 2/5. For adding and subtracting fractions, the student has to first change them to common denominators. The abacus is the easiest place to write these fractions. Write the 2 original fractions on the abacus by writing 1 on each side, leaving a space between the numerator and denominator. Let's use 1/2 plus 2/3 as an example. Write the 1/2 on the left side with a space in between the numerator and denominator, and then write the 2/3 on the right side. Now decide on a common denominator. I'm going to decide on 6 and multiply each fraction appropriately to get sixths. I'm going to multiply this one by 3 because 2 times 3 makes 6. 1 times 3 is 3. I'm going to multiply this fraction times 2. 2 times 2 is 4. 3 times 2 is 6. Now I have common denominators. Now I can add the numerators. Leave the denominators alone. So I have 3/6 plus 4/6, and I can just change this to 7/6 and then write my answer. The answer is 7/6. Try a subtraction problem now. Let's clear that. Okay, I'm going to use 7/8 minus 1/2. I will write the 7/8 here on the left, and I'm going to write the 1/2 on the right. Again, I'm going to decide on a common denominator. This time it's going to be 8, and so I'm going to multiply the 1/2 to get eighths. 1 times 4 is 4, 2 times 4 is 8. Now I have common denominators. Now I read from left to right and subtract. 7/8 minus 4/8 is 3/8. So I can just write 3/8. I'm using the abacus for intermediate steps as a place to write down the fractions and be able to read them easily to do the math. In multiplication of fractions, you can write the 2 fractions on the left and right sides of the abacus the same as we did in addition and subtraction. Then just multiply the numerators together and the denominators together. I have the student write that fraction in the center so they can check to see if it can be simplified. But they could write it directly on their assignment to show their work and then simplify on their assignment. For example, let's use 2/5 times 3/7. I would write 2/5 on the first side, on the left side, leaving a space between the numerator and denominator, 2/5, and the 3/7 on the right side, and again leaving the space between the denominator and numerator. Okay, so in multiplying, we multiply numerators. That's the first number times the first number, and then the last number times the last number. So we will multiply 2 times 3 is 6, and I write the answer somewhere in the middle. You could count back 5 rods, but you could just put it somewhere in the middle. It'll still work out. Then I do last times last. 5 times 7 is 35. Leave an empty rod in here just to make it easier to read, and then write 35 for your answer. Now, this looks really cluttered, so you could have the student clear away as they do it. They could clear away the firsts as they finish them and the lasts as they finish them, and it would be easier to find the answer. My answer is 6/35. Can I simplify that? No, so that is my final answer. Since division is the opposite of multiplication, you can divide fractions by simply multiplying the opposite. You can use reciprocals and switch the right side fraction, or you can teach the student to cross multiply, where they would multiply the first times last and then last times first. They will use the same terminology and method in algebra in using it with the FOIL method and in ratios. For example, if I want to divide 3/4 divided by 1/5, I would write the fraction 3/4 on the left side 3/4, not fifths. And I would write the fraction 1/5 on the right side, 1/5. Now, to do reciprocals, the way they're learning in class, you would flip the second number, never flip the first number, flip this one over. So 1/5 would change to 5/1. And then you would do numerator times numerator. 3 times 5 is 15. And denominator times denominator, 4 times 1 is 4. So my answer is 15/4. I'm going to clear that part and go back to our original problem of 1/5. This has one less step because you're not using the reciprocal. So when you cross multiply, you do the first times last. 3 times 5 is 15. And then the last times first, 1 times 4 is 4. And I get my answer 15/4. I get the same answer either way. Be sure to remind them to simplify if they can. In this case, we can't. Now let's take a look at decimals. The abacus has marks on the bar that can be used as decimal points instead of commas. We usually use the first mark so that there is space for tenths, hundredths, and thousandths after it. I have found that when a student has trouble with the concept of counting backwards for decimals, I have used the second abacus to the right side and put the whole numbers in their regular place and use the second abacus for the decimal, so that this becomes the decimal point. For example, if I had a number 25.385, if I wrote it the regular way, I would write 25.385. And so I found that it works really well to bring in the smaller second abacus and write the 25 in the regular place, and then they can count 0.385. Addition and subtraction problems have decimals lined up, and then they're calculated as usual. So we could do that with either all on the one abacus or on the two abacuses. So for example, I'm going to have the number 14.32 plus 25.15. I will set 14 in front of the decimal point, 0.32, and then add just as I normally would 25. So I'd add 25.15. And there's my answer, 39.47. Multiplication uses the normal method of multiplying, and then you add the number of decimal places, just the same as you would on paper. For example, let me clear that. And if I had a problem of 2.5 times 3.1, I could write I'm just going to write 2.5 times 3.1, 31. I would just have, it'd be the same as the problem 25 times 31, which is going to come out 775. So I'm just going to write the answer because I already know it. But where do I put the decimal point? My original problem had 1 decimal place here and 1 decimal place here. That makes 2. So I would have 2 decimal places here, and my answer would be 7.75. I'm going to clear that, and the same works for division. Since division is the opposite of multiplication, then you can do most problems by subtracting the decimal places to get the decimal point in the right position. So we would do a regular division problem without the decimal points and then subtract. So for example, if I have 9.25, I'm going to write 9.25 and not worry about the decimal point, divided by 2.5. That's the same as if I was doing 925 divided by 25. Now I know my answer already ahead of time comes out 37, but where does the decimal point go? Well, I had 2 decimal places here, 9.25, minus the 1 that was over here, gives me 1 decimal point in the answer, so my answer is 3.7. I hope this information has been helpful to you. If you have any further questions, please contact us.